Unless one of those cars is yours.
Samples of the liquid streams that we see here. I thought it would be cool to show you guys. That way it will kind of help, it gives you an idea of what comes in and what we do and what goes out.
You're going to drink a glass of water when we're done. When we upgraded the plant the first time, the guy said, will you be able to drink this water?
I'll watch it.
All right, good. How are you?
Good.
After you, Mr. Slocum.
All right, so this is our brand new lab. It's part of the new administration building that was built. So I asked Kyle, who's one of our operators here, to grab us some samples of the liquid streams that we see throughout the treatment facility. So this is essentially what we call influent. This is what comes into the facility. This is essentially your raw sewage mixed with a little bit of septage mixed in. This is, for the most part, the bacteria that do the majority of the treatment. This is what takes place inside the aeration basin. And this is basically, and I'll have Kyle mix this up, it'll kind of give you a better idea. This is essentially what happens inside the secondary clarifiers. The bacteria flock together, they settle, the clear liquid goes over the top and moves downstream for further treatment. And then this is essentially our final product. So this is what comes in, this is what goes out to the stream. I got two samples here of water. I know Jim said he was thirsty. One of them is treated effluent, the other one is drinking water. And it's amazing, you almost can't even tell the two.
How long does it take to get from that process to that process?
Well, a lot of it's dependent on the flow that's coming in. So, the tanks are a fixed volume.
Days, weeks?
No, this is, right now I think we're about a day.
A day?
Yeah. And that's to, to come in, go through the full treatment and go out. Obviously in the summertime when flows are low, it can take a day and a half. If flows pick up in the rain, the rain really pushes through here, it can rip through here in 4 hours, I think the treatment process altogether is like, in a perfect world, is about 8 hours. It can go from this to this. But like I said, it's all dependent on the flow. You have to keep pushing things through the system. This treatment plant's pretty unique, so everything flows by gravity. You don't really have to pump anything up to the next process. So as we move along, you'll see like the influent where it comes in is up here. I think the sea level is, let's call it 122, and where it goes out is like, I think it's 98 or something. So there's almost a 22-foot difference from start to finish, and it all just flows by gravity. So if you want to mix this up, this is, and we'll see the basins out there, but this is essentially just the bacteria. There's probably some, some feces in there too, but it's mostly bacteria. That's essentially what feces is, it's bacteria. And then the bacteria mix, the raw sewage mixes with this bacteria, and we create more bacteria. And what we do as operators here is we constantly look at how much bacteria do we have, and how much do we have to remove from the system. And then, we process it, it gets dewatered, I'll show you guys that, and then it gets hauled off site and gets burned at an incineration facility. So it's a pretty unique process. It's constantly changing. It never stays the same. Every day we work 7 days a week here, 365. We have to grab samples, check the pH, check all our numbers, the equipment.
How do you remove the heavy metals?
For the most part, Jim, it just happens. The bacteria, I think they absorb it into their cells. Metal removal is a really tricky one. But I think what they do is they absorb it into their bacterial cells, and then I think some of it does get removed a little bit with the chemical, but mostly biologically. Yeah, like I said, that's essentially what happens, and I kind of wanted to do this for 2 reasons. One, to kind of show you guys, but as some of you may know, the secondary clarifiers unfortunately did not get touched during this project, so those are still 35 years old and probably going to need to be replaced in the near future. So again, this is what happens in the clarifiers. They're large circular diameter tanks that are designed to slow down the velocity, and it allows the solids to settle. If we step away for 15 minutes, this will probably end up like this down here. So the bacteria, they flock together, they settle and they compact, and we need that to happen because this is what the clear liquid is that goes down the stream. This bacteria, if this goes into the river, that's a big no-no to the DEP and the EPA, which is who we're regulated by. And that was the driving force behind this upgrade was every 5 years we have to renew our permit. So we have a permit that the DEP and the EPA they permit us to discharge treated sewage into the Forget-Me-Not Brook. Every 5 years you have to renew that permit. And they typically always adjust the limits every 5 years. Well, the most recent one, the limits got so low that the current process could not meet those limitations, so we had to have upgrades and new processes added. So, but the reason the clarifiers are so important is, like I said, this bacteria, we want that to stay inside the treatment plant. Anything that escapes to the river causes major problems. And you can see, just from a simple, just sticking this in, that right there, going to the river, that's a big problem. We have to test for BOD, which is just a fancy word for biochemical oxygen demand. So it's the amount of pollutants in the liquid. And we test for TSS, which is total suspended solids, total phosphorus, many different forms of nitrogen, E. coli, aluminum, copper, zinc. These are all things that we have to test for and remove, and we can't discharge out to the. So for instance, coming into in this sample right here, your aluminum could be up to 1,500 parts per million, and we're only allowed to discharge 107. So it's just little things like that. You've got to. And you can see, just from that one little stir, it causes this turbidity, we call this, but you can see this is already settling pretty good. Our settling is pretty slow right now. It's a lot better in the winter. The bacteria are affected by temperature.
Cool.
Yeah, just like humans, they breathe oxygen like us, and they don't like the cold. At least I know I don't. But all right, I'll take you guys through and show you each little.
Gonna call back.
Yeah.
Hope you guys brought your walking shoes. So we'll go all the way up to the Headworks, which is where all the raw sewage enters the treatment plant. Just be careful, it's a little slippery with some black ice. So this building is our brand new septic receiving building. Basically, septage haulers that they can bring their trucks in, they can pull up here, they connect their hose to the discharge hose, and then they now have, each hauler has a card. They just swipe in here, they punch their pin in, and there's a valve inside the building that opens up and allows them to discharge. In the ground here, buried below the ground, there's two 20,000 gallon holding tanks. So we have a capacity of 40,000 gallons. This is really helpful because before it used to just be a slug right into the building, and it really affected the treatment for the aeration basins. It's too high of potency food too quickly for them. So by holding on to it, we can bleed it slowly into the system. and it really helps with the treatment process. I'll show you guys this in here if you guys want to see. This is essentially just a big screen in here.
I love that smell. Sticky.
So this is the septic receiving building. This is the pinch valve I was telling you about. This basically allows us to, it permits anybody that's not authorized to dump here to not be able to dump. If this valve doesn't open, they can't dump. So once this opens, it goes through this rock trap. This collects any rocks or any heavy grit that could harm the machine. And it goes through flow measurement, which is something we never had before. Before it was all on the honor system, so somebody could bring in X amount of gallons and they could fit. Well, I don't think we had too much of that, but then it goes through, follows the pipe, goes through this big screening mechanism. As you can see, the screens fall into here, and then the liquid goes down to the holding tanks and gets held.
So this is all, I remember Rob used to call it cake.
No, this is actually, cake's in that building over there, Jim. I'll show you that after. This is just the screens that comes out of any screenings, rags and stuff that comes out of a septage tank.
Okay.
We want to keep all these rags out of the treatment process because they get clogged in the impellers of the pumps and they really wreak havoc.
How many haulers do you have that dump there?
I think we have 8 that are permitted. Yeah, which is quite a bit. I mean, we wish it was a little more. I'll take you guys into the headworks. This is where all the raw sewage comes into the facility. So this is Headworks. This is where all the raw sewage enters the facility. It all enters there through 18-inch pipe. It goes through this mechanical screen. This collects any rags and most of the stuff that's not supposed to be flushed. And inside this hollow tube here is a shaft. The shaft, it runs so much throughout the day and it drags all the rags up and discharges it into the bucket there. You can kind of see what the inside of the screen looks like. Essentially just a big, we call this a rotomat. This is brand new, this was replaced. So all the rags catch on those quarter-inch screens. And as the level builds up from the rags, we have 2 level transducers on each end. And they're monitoring the level. So as it builds up, once it's a foot difference, it turns the screen on. It collects all the rags in the center, augers them up to the bucket and dumps them in there. Then they get dumped into that dumpster outside. And eventually, like once every 3 months, trash company, I can't think of their name, they come and they pick it up and it gets hauled to the landfill. This is called a Huber Conda. Conda is just a fancy word for that. I think the way it's basically this is a grit removal. So grit is like your sands, rock, anything that makes it through the pipes into which is we get quite a bit of it. So down inside the grit chamber, there's an auger, another submerged auger, and a submerged pump. So every so often, it's about every 8 hours, they'll turn on. The augers the grit to the pump pumps it up into this. This separates basically anything that's not like sandy. It'll flow over the top and go out to the next process, and all the grit collects to the bottom, and eventually it'll auger up into the bucket over there. Kyle, is there any sand in there? It's really, we call it the grit separator. And the grit is really, it's important that we remove that because it collects in the treatment tanks and takes up a lot of volume. And it also is very abrasive, so it'll wear out the cast iron on all the pumps, and then you'll come into a flooded basement. Sweet. Cool. All right, so once we go through, we call this preliminary treatment. Actually, one thing I skipped, I want to tell you guys. So at the treatment plant we have 3 forms of treatment. There's physical, biological, and chemical treatment. So physical is this here, when you physically remove rags and grit. So then once it leaves Headworks, there's a big pipe underground. It flows. Be careful, it's a little slippery right here. We call it the influent. The influent flows down to this structure here. This is called structure A. So it's basically just a splitter box. Everything flows up from the middle. We have the sludge that's settled in the clarifiers. That gets pumped back. So you have your bacteria that gets mixed with the raw sewage. And then it flows over the weir here. And it goes into each basin. We have 2 different basins, A and B. It feeds them equally. And then this is where all the biological treatment happens. This building here, I'm not going to take you in there. It's pretty nasty chemical in there. This is called sodium hydroxide. We use it for pH and alkalinity, but it's very corrosive. You get it in your eyes, you're not going to be seeing it out of those eyes ever again. So I'll keep you guys out of there. Plus it's a little slippery. We call this mixed liquor. Bacteria and raw sewage mixed together. And we have two different weirs that it flows over. Train B and train A. So after it flows, the aeration basins. This is where 80% of the treatment here at the facility takes place. So like I was saying, we have raw sewage mixed with the bacteria, and this is where, you know, they spend a lot of the time under aeration and the treatment happens. So as part of this upgrade, we converted these used to be 4 different basins. Now there's what we call 2 trains, and then we put some baffle walls in place, and we created different zones. So as you can see, some of these zones don't have any aeration in them, and the other ones do. So essentially, without getting too into it, what happened is, in this first zone here, this is designed to remove total phosphorus. The second zone is designed to remove total nitrogen. And then these last 3 aerated zones, this is where they remove the BOD, it's really, it's the majority of the pollutants get converted from some whatever pollutant it is to basically new bacteria. Most of your pollutants that come in here get converted to new bacteria. And then so it goes in, it flows in a plug style, so it comes in on the end, goes through the zone, and that's what the baffle walls do. It keeps everything flowing in like a maze type. And then you can see we have, these are the air pipes that feed the oxygen to the basins, and these are electrically actuated valves, so they open and close based off of the demand, the air demand to the system. And as you can also see, we've got a lot of different sensors that are mounted on the railings. These are continuously monitoring different parameters, such as dissolved oxygen, ammonia, several different forms of nitrogen, ORP, TSS. There's just so many things that we have to monitor and constantly track here. Is there any questions so far? All right. So like I said, this is the majority of where the magic happens here. This is the treatment. This is essentially where the whole town, anyone who's connected to sewer, this is where your sewage flows and undergoes treatment. It's a pretty neat little process. In the wintertime, in the morning, when you walk through, there's like an earthy smell. And it's just a smell that you just, as an operator, it's just you love it. It's a good smell. I can't explain it, but when treatment is going good, it just, the smell kind of signals that. All right, I'll take you guys down here. Actually, give you a little rundown on this. So these zones are, like I said, these are designed to remove nitrogen and phosphorus, but we do not want to aerate these because we don't want any oxygen in there. So what we do is we have big compressors that I'll show you, and these just provide a burp of air, which is run through this EnviroMix panel here. And as you can see, it just provides a little burp of air to keep the bacteria in suspension, because if we don't, they'll settle out like I showed you in the settleometers. So you can see every 45 seconds, each zone gets a little burp of air to keep things in suspension. These three units here are the aeration blowers that provide the oxygen to the basins. Everything's brand new. They're just big positive displacement blowers. I took this off here so you guys could see in there, but it's any interest you can look. But it's a big 50 horsepower motors and big blowers. Everything here is automated now, which we didn't have before. So these machines will speed up and slow down based off of the concentration of pollutants that come into the facility. So as the bacteria see a greater, when the flow picks up and you see like if Vibram is dumping something that's a little bit nasty, the bacteria will know that, and they'll start to chew up that food. It's all food to them. And then the oxygen will go down because the bacteria, as they break down the waste, they also consume oxygen. So the sensors out there will notice that decrease in oxygen. It'll cause the bees to speed up. The blowers will speed up, put out more air, and everything's all automated. These are the two compressors that provide the compressed air to the little zones out there that just have the little compressed gas burping. So like I said, we have redundancy. They give you 3 because if you don't have any oxygen, you'll be in violation within 12 hours. You'll be up shit's creek. So, you got to have redundancy here. In the summertime, the water temperature really affects the bacteria, so as the water heats up, there'll be a demand for a second blower to be running at all times. They consume more oxygen when the water temperature is higher, so you typically only have one backup if something goes wrong. As I was saying, most of the electrical here has been replaced, so this is all pretty much brand new electrical, all new switch gear, all new circuit breakers, surge protectors, all that happy stuff. We have a bunch of control panels throughout the treatment plant. I know some of you guys don't really care, but this is where we make all the adjustments to. There's a lot more that goes into this than just a piece of equipment. It's, setting things at the right set point, understanding how the things are constantly changing here. It's not just a set it and forget it. Every day we gotta look at things. Okay, this happened. We gotta adjust this set point. There's a lot of work that goes into constantly meeting. We have to meet permit compliance 24/7, 365. We test every day, and we report that data that we get in the lab. That goes to the DEP and the EPA. This is a pretty neat little process.
This equipment's all new to you, right? So the education process.
Yeah, there was yeah. That's what I was saying. It was very overwhelming. But, burning everything, and yeah. You got to read you see the manual for that. You got to go through that.
You're gonna be looking at that all the time, especially when you're not used to the equipment.
I think we got 40 manuals, and you got to go through and figure out. Nobody tells you what the maintenance is. You got to figure that out on your own. So this isn't running right now, but what this piece of equipment is this is called a belt filter press. So this is a belt filter press. So as I was telling you guys, we create bacteria here. So and we got to keep that bacteria out of the river. So every day we do some math calculations, figure out how much bacteria we have, how much do we have to remove. So when we remove it, we put it into some holding tanks out there, we thicken it up, and then when the tanks are full, we pump it to this belt filter press. So all this is basically two filter belts, and the sludge comes down, falls on the belt, the water filters through, and then it comes down and falls through this, and then it gets squeezed between the two filter belts, and then these pneumatic cylinders put tension on the belt, and the tension kind of does two things. It helps with the dewatering, but it also squeezes the cake. The reason we dewater is we pay by the weight here. So obviously the more water we can remove, the less we pay. And somebody recently said to me, why are the sewer rates higher than the water rates? Well, the cost to haul solids off-site is the biggest line item in our budget. It's about $250,000 a year. And the water department doesn't have that. They don't have to remove. There's a lot of things that they don't have that we do, but that's one of them. $250,000 is 20% of our budget. So,
Processing all the stuff that they filter out.
What's that?
Aren't you processing here all the stuff that gets filtered out of the drinking water?
Absolutely, yep. The water department is, I think in the summertime, they make up like 35% of our daily flow. Just all their backwash pumps in here. So, but this unit did not get touched at the upgrade. This is from '94, this is original. It has very low hours. We're a small treatment plant, so we only run this once or twice a week. Whereas if you go to like Upper Blackstone on Route 20, they have 3 of these that run 24/7. So once the sludge goes through all the different zones, it gets squeezed out, it falls onto this conveyor belt, gets conveyed up, and then it falls into this 50-yard dumpster over here. And we have a contractor that comes and picks it up once a week and takes it and burns it at an incinerator. And you guys, if you're familiar with Route 20, going into Millbury, they got the big treatment plant on the left. That's Upper Blackstone. And there's a big, tall stack there. That's an incinerator. So they burn sludge from, many surrounding communities. This stuff goes to Waterbury, Connecticut. We're contracted with a company called Synagro. They take it to Waterbury, Connecticut. It gets burned down there, but Upper Blackstone does the same thing. And this is becoming, so the biosol is what comes off of this. This is becoming increasingly difficult to get rid of this. The EPA keeps putting all these strict mandates on the sludge. So what's happening is the cost to get rid of it keeps going up, you know. When I started here 10 years ago, I think we were paying $105 a wet ton. Now we're up to $185. It's almost doubled in the 10 years that I've been here. You know, and all that cost goes in, like I said, it goes into, you know, into the sewer bills and all that. So it's, you know, nothing, obviously, you guys know everyone pays bills. Nothing ever gets any cheaper. You know, I'm always trying to find ways to save little bits here and there, but it's tough. You know, I think there's a 25% increase in health insurance this year, and, you know, and that's pretty significant. So it really gets pretty tough. But any questions on this?
There's no agricultural use for that waste, huh?
No, there is. It's tough because I think like in the Midwest you can do that, and you can offer this to the public, but there's like licenses you need to get. Southbridge does it, but it's really tough. It's not worth North Brookfield to go and do that. And even like in Maine, they recently the state of Maine, the DEP up there, they put a mandate so there's no more land application. So, you know, they used to just take their biosols and landfill it, but you can't do that anymore. So they're trucking their stuff down to like Alabama and the Midwest, and the cost for that has gone up from what I read 400% or 500%. You know, so those are all the things. You know, you don't ever think about sewage and where where it goes, but the biosols is really. You guys might have heard of PFAS. That's a new one that the PFAS is inside the sludge, and they're constantly putting all these strict limits on it. So it's getting harder and harder to get rid of it.
All right, keep moving on.
City of
All right, I'll take you into this building. This is what we call the operations building. So this is where we house what we call polyaluminum chloride. This is a chemical we use to remove the phosphorus. And basically, you dose it into the liquid. It converts any soluble, which is like if you ever put table salt into a cup of water and stir it, it dissolves. That's a solid. Now it's a soluble salt. So anything that's soluble, this chemical here will convert it into a solid, and then it gets filtered out down at the filter room, and I'll show you that down there. But we have on the printout there, North Brookfield has probably the top 5 toughest permits in the Commonwealth that I'm aware of. I mean, I think there's a couple hundred treatment plants throughout the state, and because we discharge to a really small brook, the limits, because we don't have any dilution, that's how they look at it, the limits that we are allowed to discharge are very low. Yeah, we haven't been able to stop that darn leak.
Oh my goodness. Stop the noise.
All right, so this is what we call the operations building. We have all new control panels here for the RAS pumps, which are downstairs. RAS is just a fancy word for return activated sludge. So when the bacteria settle in the clarifiers, that all has to get pumped back to that structure A I was showing you over there, and that starts the new. It gets mixed with the raw sewage to start the treatment all over again. This is our small chemical feed setup here. So this chemical inside here is called polyaluminum chloride. It's basically, the only reason we use it is to remove total phosphorus, which is one of the limits on our permit that we have to meet. So we got some chemical pumps here. It's all piped through the ground and it goes out there. Don't mind the leak in the ceiling, that's something we've been battling, and we addressed it at the upgrade, but apparently it didn't hold, so. We got some VFDs in the wall over there, that's for our plant water pump, so we have what we call plant water, so all the treated effluent some of it gets pumped back and gets held in a storage tank, so anytime we do hosing throughout the facility, or some of the equipment, some of the pumps require water to the seal, we don't have to use the town's drinking water for that, so it saves us money, it saves them, valuable drinking water, and we just use the treated effluent. And then we have over here, this is kind of neat, this is something new to us, so these are all the flow meters, so we measure the amount of flow that the RAS pumps are pumping, and that's a really important parameter for us. I won't get too into it because I'll confuse you guys, but we didn't have this in the past, so we were always just guessing what we were pumping, and it does create some issues for us. So, like I said, right now this is showing 450 gallons a minute that we're pumping. And then the automation, we have two different clarifiers, so the automation controls the flow from each clarifier so you can equalize it. In the past, we used to pull a lot more flow from one clarifier than the other. It's just the nature of the beast. But now with the automation, it'll slow one pump down and it'll allow you to equalize the flow from each clarifier. If anybody's interested, I can take you downstairs. It's kind of a windy staircase. Pretty neat little setup down here.
Brian, you go to the senior center? Go to the senior center?
I'll go down and see what they come. Yeah, yep, that's a requirement. Yeah.
Smell what?
All right, so this is the ops basement. This is where most of our pumps are. So these three, actually there's one in there, these are called RAS pumps. So these are returning the sludge from the bottom of the clarifier and it pumps it back to the aeration basin so they can keep doing the treatment. Everything's a constant loop here with the sludge. So it comes in, goes into the basin, mixes with the raw influent, goes through treatment, goes into the clarifier, settles in there, gets pumped back, and then goes back to treatment. And every day, like I was telling you, we remove so many solids, and I'll show you the holding tanks that we put those in. But it's basically just a constant loop, and it's just the bugs are just constantly always breaking down the waste. So these little pumps, these are about half the size of the old ones. Believe it or not, these will pump 600 gallons a minute. These are all automated. They turn on and off based off of set points and timers. And inside here, these are the plant water pumps I was telling you about. So on the other side of this wall is a plant water storage tank. It's basically just treated effluent. Effluent is just treated sewage. So that gets stored there and it gets piped, and anytime there's a demand for water, when we open up a hose, goes one of the tanks or whatever, these pumps will turn on and they provide up to 60 pounds of pressure. And obviously you can see this valve, and you can close the valve and send it to one different tank, open it, it's constantly sending it to different places. Everything's color coded, all the pipes are color coded. It's not a law, but it's a requirement. So you can see the blue, the aqua sky pipe is a Clarifier 1 and Clarifier 2. That white pipe back there, that's domestic water that's coming into the building. That's a 2-inch domestic water line. Before the upgrade, these pumps were inside this room. These pumps were outside here, so we had a bunch of room in here, and we used to have to shimmy our way through to get into this room, and there was no room, you're constantly smashing your head, and so we moved everything out here. We just did a swap around. It's been really helpful for us. We have to pull these pumps apart. As you can see, we have the chain fall. So we hook the chain, the hoist up, and we split the pumps here. We pull them up and we derag them once a month. So you can imagine it gets pretty tight in here. These red pumps over here, these are positive displacement. We call them the Penn Valley. So these pump the thickened sludge from the holding tanks to that belt filter press we just looked at. So they're just essentially sludge pumps. And these are original. These did not get, oh sorry, that's the figure. None of this piping got replaced at the upgrade. So these pumps are, I think that they're, actually that pump Mike and I put in when I started working here about 10 years ago. But this pump is original from '94. Now obviously there's all new electrical down here, all new piping. One thing we didn't have, which I wish we still did it, is a fire detection system. That was, you know, obviously now that's a code now, so they had to run fire detection throughout the whole place, and it's just been a nightmare. We constantly get false alarms and people coming in at 2 a.m. to chase nothing that's there. Any questions? All right. Now, can you throw those buckets back on that leaf for me?
Be ready for something. I'm just gonna bring the tools up.
Hope I'm not boring you guys.
Very
Interesting.
You're not bored yet, are you?
Not at all.
I know it's kind of hard for you guys to picture what I'm saying, because it is pretty technical, but these are the sludge holding tanks. So after, and I probably am doing this a little bit backwards, but after everything leaves these aeration basins, it flows into the clarifiers. And some of you guys missed the little presentation we had, but essentially what these clarifiers do is it slows down the velocity of the flow, and it allows the solids to settle to the bottom. We want to keep all this bacteria in this treatment plant. Anything that goes out to the river is a no-no for us. So once it settles to the bottom, those RAS pumps either pump it back to the head of the aeration basins to do the treatment again, or we dump them into these holding tanks. These are just sludge storage tanks. So once we waste so much, and then usually about once a week these are full and they're ready to be pumped to the belt filter press to have the solids dewatered.
Don't fall in there.
So like I said, as operators, one of the main objectives we have here is to figure out how much bacteria we have, and that changes every day. The more septage we have, the more bacteria we have. And there's a fine balance. You can have too many and not enough. So every day we take samples, we do math, and we figure out, do we need to waste 20,000 gallons, 60,000? And then now that we have the automation, we can go sit right on the computer and say waste 47,302 gallons. You hit the enter button, and one of those pumps will turn on and it'll pump it into this. And then once it settles in here, like some of you guys didn't see, but the bacteria will settle and the clear liquid stays on top. And these two Mike's wasting right now into here, it just started it. So the clear liquid can get drawn off. If you don't want any clear liquid here, the goal is to keep as many solids in here as possible. So all the clear liquid flows into this pump station over here. This pump station actually collects in here and then pumps it back to the head of the aeration basins to go through treatment again. You know, there's a lot more than you can see. Like I said, there's a wet well, there's tons of controls and floats and level sensors and all types of pipes and valves and you know, obviously everything's hidden, you can't see it, but it's there. So basically, once everything flows out of the basins, it goes into the clarifiers over here. So this is what we call structure B. This is just a splitter box. So all the flow that comes from the two basins, the two trains, flows up from the middle and then it equally feeds, falls over a weir, and then feeds clarifier 1 and 2 equally. And then the sludge settles, comes in from the center within the center ring, and then it comes in and then settles to the bottom. All the clear liquid goes over the top to go downstream for the next process. And then what we call RAS, the RAS, return activated sludge, the bacteria get pumped back to the basins to continue the treatment process.
Now, these are the things that are getting replaced now.
Yeah, so these did not get touched. They were supposed to, but we learned right from the get-go that there wasn't enough money in the project. So these did not get replaced, but they're in need of it. They're original. They're almost 35 years old and they're in pretty rough shape. This one, as you can see right now, this one has a blown seal, so it's leaking oil. And everything's obsolete, so you can't find anybody, you can't buy the parts anymore. So you have to just replace it. I've tried to reach out to machining companies to see if they can, and you don't get anybody, they're not interested, you know, it's too much work. But essentially, you can see these are a little dirty right now because it's difficult to hose anything this time of year. As you can imagine, everything freezes. But you can see, if you look closely, you can see the sludge entering the clarifier. So that will eventually slowly settle over time, and then the clear liquid goes over the top and then down to the next process. And you know, one thing that's interesting to point out, so these hadn't been cleaned in about 2 weeks. You can see how much algae builds up on the weir. That's what happens in the river if you don't remove all the phosphorus. That's why the EPA and DEP hammer us, because you choke out the rivers with all this algae if you don't remove it.
That makes sense.
I don't know what those floaters are. I don't know what floaters.
Yeah, those are pieces of grease.
Oh, really?
Came off the pipe.
You have to clean that out of the
Oh yeah.
water too.
Yep. I mean that we'll probably just once a week we just skim it out and then we dump it. Anything that collects on the surface of the clarifier, that skimmer arm comes around and skims it and dumps it into, we call that the scum bead. And then this is a scum holding tank. So everything will fall from that into the holding tank. Then once a week we pump it into the holding tank, and then we do that prior to running. You missed all the belt liquid stuff, so I can show you that. But it all gets processed and sent to the incinerator to get burned. All right, so actually we can walk this way. I'll take you guys down. So once the
In the middle
flow-
tank, the floaters.
once the flow leaves the clarifier, it goes down to the new filter building down there, and it gets filtered, and then it goes through UV disinfection, and I'll explain that down there. So we can take a walk down there.
Live and learn.
Yeah.
Next year. What are you doing? What are you
Alright, so this is what we call the CMF Building, stands for cloth media filter. So this is where the filtration happens. So after the effluent leaves the secondary clarifier, it flows down to go through the filtration process, and then the very last step is UV disinfection. So we're required to disinfect the effluent is just a fancy word for public sample. So the effluent is disinfected prior to being discharged to the river. And we do that using the ultraviolet light. So we're only required to disinfect from April to October. So at the end of October, the staff can pull out the bulbs and we clean everything, we winterize it. So that's what you can see there. Those are the UV bulbs. There's 14 modules, which is a whole set, and I think there's somewhere to 80 bulbs, something like that. So those are the big, it's a big white, UV light, and it actually, what it does is it doesn't kill the bacteria, but it destroys their DNA and prevents them from reproducing. We have to test for E. coli here, and we do that because that proves that if the E. coli don't grow, that everything's killed and everything's been disinfected. If anybody's interested, we can take a walk up here and we can see what the filter looks like. It's essentially just a big sock. The water has to flow into the tank, and then it filters through the sock, and inside of the filter there's a pipe in the middle. So the water flows into that and then goes out through that big green pipe there labeled effluent. And then down here these are the cloth media filter pumps. So every so often these pumps will do a backwash, so they'll suck any of the solids that collected on the filters, and it'll pump it back to the head of the process with some of the different people.
You're doing great, Eric. You're doing
You
great.
guys want to see it go? Processes. That's in case something fails, we can switch over and go with the other one. So this is our offline cloth media filter. So the water enters through this pipe, flows over the weir, and like I was telling you, that filter is hollow, so the water has to filter in through that sock, and then the shaft that's in the center, it collects through there, goes out, it flows over the weir that the guys are standing on, and then goes out to UV disinfection. Without this filter, we would not be able to meet compliance with our permit. This actually filters any real suspended solids, and the suspended solids is what the TSS we call it, because it's loaded with phosphorus, because the bacteria absorb the phosphorus into the cells, so if any of that TSS makes it into the effluent, it shows up as total phosphorus, and you have a permit violation. That's one of the reasons why we had to do this upgrade, was because we could not meet our total phosphorus limit. And we went from 0.2 milligrams per liter down to 0.1. It doesn't sound like a lot, but it's a world of difference in the treatment side of things. So I didn't show you guys because it was kind of tough to see, but up at that structure B, right before the clarifiers, that's where we dose the pack. So it goes into there, and then it has time to mix with the clarifiers, and then that pack mixes with the dissolved phosphorus. So we have two forms of phosphorus removal. Chemical, we remove the dissolved portion of it, and this is the particulate. So anything that's a particle gets filtered here and removed. And then this changes, spins these filters, and then in between these filters there's little vacuum feet, and that's what those pumps do. They suck, they provide a vacuum, and as that spins, it cleans the filter off and sends everything right back to the head of the plant to go through treatment again.
Very cool.
Alright, so after filtration, the liquid comes through here, and like I said, these scales are empty right now. We'll pull the bulbs out, but starting in March, we'll put the bulbs back in, and essentially these are, this is where we disinfect through here. Once it goes through disinfection, it flows through this channel and goes down through. This little neat thing here is called a partial flume. So what this does is it chokes the flow down to a 9-inch throat, and there's a certain formula that says at a 9-inch partial flume, X amount of inches equals X amount of flow. So these little sensors here, those are flow meters. So this is where we measure the final flow out of the plant.
Hey, Eric, what kind of educational background do you have for all this? This is really intense. Like, this is a lot of information.
Yeah, there's a lot that goes into wastewater treatment. That's why I'm glad you guys are here, because you can kind of get a feel for it. Like I said, this is 365, 24/7. The equipment never stops running. Everything's constantly changing. But a lot of this for me is on the job. Like,
wow,
even like chemical engineering, and this is a pretty unique skill set.
Yeah.
So a lot of it's on the job. I've been in the field about 15 years.
Okay.
I've been with North Brookfield for about 10. Prior to that, I worked for Spencer for a year, and I worked in started my career in Westboro, town of Westboro.
Okay.
Which is on the job training and an interest. I mean, I really, I never stopped reading, never stopped studying. I do have just about the highest license you can have in the state, which you need. This is now a grade 6 facility. Okay. Prior to the upgrade, it was a grade 5. We recently had a DEP inspection, and it got bumped up to a grade 6 facility. So anybody that manages this place has to have the highest license in the state. Yeah, that's just on the job training and the passion for wastewater treatment, really.
Cool.
And this is about the last process in the treatment system. This is a final effluent sampler. So it's just a pump here. This pump is down in the liquid, and we can set whatever we want to set here. And we're actually sampling today, so this will collect a sample every 15 minutes over the course of 24 hours for a total of 96 samples, which is about 2.5 gallons. It collects 100 mils a sample. So we have so basically every 15 minutes you're sampling what's leaving the plant, so you almost can't miss anything, right? And that's a requirement from the state. They tell you exactly how often, how many samples you got to take. So this is called the composite samples. Tomorrow we'll collect this and we'll run a series of tests on it. And then we report all that data to the state. And they either tell us that, hey, you're in compliance or you're out of compliance. After the upgrade here, we've been complete for several months now. We haven't had any compliance issues. The plant's running well. Hopefully that it stays that way. Like I said, things are constantly changing. What comes down the pipe is constantly changing. How much septic we take is constantly changing. What's in the septic, it's a constantly ever-changing, very volatile system. I suppose I can show you guys the last. So after flow measurement, it goes to what we call this the fish ladder. So it's basically just a couple concrete steps that are designed to provide turbulence into the water. It provides DO oxygen into the water before it goes out to the forget-me-not brook. We also have a small pump in there that we pump the treated effluent back to the plant water storage tank. Like I was telling you, we can use the treated effluent for things like hosing and watering the grass, and that way we're not using treated domestic water for those things.
You can see that treatment that is large, you can pick this up.
The only thing we have to test for is E. coli. Yeah, we don't have the ability to test for any viruses. We did do some COVID testing.
I was going to say, remember when they were testing all
Yeah.
of that wastewater for COVID?
We did that for about 18 months, and of course, the results to come back, you got 653 billion viruses in the earth, so we didn't really know what to make of it.
That just aerates it.
That just provides turbulence. So this is the last process here, like I was saying, this is called the fish ladder. So it's just a couple concrete steps that provides oxygen into the effluent, and then it goes out to the forget-me-not brook. This brook here eventually flows down to the 7 Mile River. It meets up and then goes into the Quabog Pond, and then it goes out. Then it goes through the 7 Mile River, catches up to the Connecticut River, and goes out to Long Island Sound, and ends up in the ocean. So that's essentially the wastewater treatment plant. Very good.
Thank you.
Good job.
Thank you. This is really cool.
Welcome. I guess a little fact I didn't get the chance to tell everybody, but so this plant is designed to treat 800,000 gallons of sewage a day. Right now we're flowing like 350, so we're about a little less than half capacity. I tell the selectmen all the time, like, I'd love to see like another Edna Circle, because the lower the customer base we have, the higher the sewer bill. So if we could add some new customers to that to make up that budget, it only helps everybody. And we have plenty of capacity, Once your treatment plant is flowing to 80% of the design capacity, that's when the DEP says you can no longer take any new sewer connections. And we're not anywhere near that yet. So if we could get like a hotel or another Edna Circle, or you go up past like Witt Drive, you got all that farmland. I'd love to see a big development, something be built up there. That'd be wonderful.
I think a lot of people would like this.
Yeah, I would agree.
That's very cool. Does the wastewater